Good morning, everyone. Today I'll continue the same chapter, Trigonometrical Identities. In previous video, I had done few sums based on identities and given you formulae. I hope you all have memorized the formulae. So let's continue some more sums, and it's a fast chapter, so at least 3-4 videos are required to complete the exercise. Question number 10, part 2. Question says that prove 1 plus tan square a divides by 1 plus sec a equal to sec a. You can solve this one using identity, or you can solve it using quotient property. So I am using identity to solve it. Take left hand side, copy as it is. Now 1, you write 1. If you look at the identity, this tan square has a formula. Tan square theta can be written as sec square theta minus 1. So similarly, we can write tan square a as sec square a minus 1 whole thing divides by 1 plus sec a. 1 plus, now we use algebraic formula to expand it. A square minus b square equals to a plus b, a minus b. So when you expand it using algebraic formula, this can be written as sec a plus 1 sec a minus 1. And I'll arrange this denominator. With plus sign, you can arrange it sec a plus 1. With minus you cannot, but with plus you can write any order. Numerator and denominator cancels. You are left with 1 plus sec a minus 1, open the bracket, 1 plus sec a minus 1, minus plus cancels, which is equal to sec a. Therefore left hand side is equal to right hand side proved. Application of formula here, then algebraic expansion, cancellation. So in only one case we use trigonometrical formula, then we use algebraic formula and simplify it. I'll give you a similar question, you can do it yourself. 1 plus cot square theta divides by 1 plus cosec theta equal to cosec theta. Use similar steps, identity, change it, algebraic expansion, then simplify it. Question number 11. Please be attentive. Pay attention, this will be bit. Question number 10, part 3. Question says that 1 plus sec a whole thing divides by sec a equal to sine square a divides by 1 minus cos a. Look at this one. Copy the left hand side. Do the simplification, use reciprocal formula to change these two. 1 plus 1 divides by cos a, because sec can be written as 1 upon cos. Similarly 1 upon cos. You have fractions at numerator, take LCM. LCM is cos a, cos multiplies 1 is cos a plus 1 divides by 1 upon cos a. Cos A is new denominator, cos A is denominator. You can cancel directly here, or you reciprocate. Cos A plus 1 divides by cos A multiplies cos A divides by 1. Reciprocal. Similar, you can cancel directly in this particular step, or you reciprocate it. You are left with 1 plus cos A. Cos A plus 1 at numerator and 1 at denominator, so you don't have to write it. On the right hand side, you have to prove sine square A. So arrange this 1 plus cos A and then rationalize it. You have plus sign, so you multiply by minus 1 minus cos A divides by 1 minus cos A. This is called rationalization. A plus B multiplies A minus B, so we get A square minus B square. So at numerator you can simplify and write something like this: 1 plus cos A, 1 minus cos A. Denominator you write 1 minus cos A. A plus B, A minus B, directly you can write it as 1 minus cos square A, because square of 1 is 1, divides by 1 minus cos A. Now use identity. 1 minus cos square A can be written as sine square A. So at numerator you get sine square A divides by 1 minus cos A. Left hand side is equal to right hand side proof. Slightly confusing and it's longer. Similar question you can do as homework. 1 plus cosec A divides by cosec A equal to cos square A divides by 1 minus sine A. Try this sum in similar steps. And you have to keep practicing this exercise, otherwise you'll forget. Each and every sum has different steps, different methods to solve. Question number 10.4. This is an important sum. Please do practice this. I'll do another sum similar to this. Cos A divides by 1 minus sine A equal to sec A plus tan A. Look at this question. You have minus sign and on the right hand side there is plus sign. Two different opposite signs are there. So whenever you see two different signs, you have to solve it by rationalization. Copy the left hand side. And you have to rationalize the denominator. It has minus sign, so put multiplication, you multiply by plus. Similar term, but plus sign. This method is called rationalization by looking at the sign on the right hand side. Numerator multiplies, so you get cos A multiplies 1 plus sine A. Keep inside bracket 1 minus sine A, 1 plus sine A. You cannot simplify numerator, so keep without changing it. Use algebraic formula here. A minus B, A plus B directly can be written as A square minus B square. So what do we get? We get 1 minus sine square A. After using algebraic formula, then you have to use identity here. 1 minus sine square cos A bracket 1 plus sine A 1 minus sine squared can be written as cos square A. Identity. Cos from numerator and square from denominator cancels. You are left with 1 plus sine A divides by cos A. Square means there are two cos, one is cancelled, one is left. You have single denominators, so divide numerators individually. 1 divides by cos A plus sine A divides by cos A. 1 divides by cos is equal to sec A. Sine divides by cos is tan A. Left hand side equal to right hand side, proved. You have to be very attentive and uses of formula, rationalization. Then you have trigonometrical formula here, identity. Then you have reciprocal and quotient relation. Question number 10 part 4, you can do it yourself in similar way. It is a bit confusing and slightly complicated exercise. Question number 11, one is similar. You have to solve it by rationalization. Look at question number 11 part 2. You have 1 minus tan square A divides by cot square A minus 1. You have to prove it as tan square A. And it's simple exercise, simple sum. Numerator you write without changing. 1 minus tan square A. Use reciprocal formula here. Cot can be written as 1 upon tan. Tan square A minus 1. Keep numerator 1 minus tan square A. Take LCM at denominator. Tan square A. So 1 is written as it is minus multiplies here, you get tan square A. Now reciprocate it. 1 minus tan square A into tan square A divides by 1 minus tan square A. Cancel 1 minus tan square, 1 minus tan square. You are left with tan square A. Therefore, left hand side is equal to right hand side, proved. Techniques to be used, and you have to look at the sum. Which one you should change so that you get tan on the right hand side. So more you practice this, you'll get used to of the sum method. It doesn't have any theory portion. Theories are there. Explanation of theory will not help you. You have to keep practicing and understand the steps. And once you know the steps, you can solve similar sums easily. Question number 11.3 is similar to that of 10. 10 part 4, rationalization. Now look at this question number 12.1. I'll be doing similar sum. You can try question number 12.1 yourself. Cosec A plus 1 divides by cosec A minus 1 equal to 1 plus sine A divides by 1 minus sine A. It had come in ICSC, so please look at this one. Left hand side. You have to get sine on the right hand side, so this cosec you can change into sine. Reciprocal relation, 1 divides by sine A plus 1. 1 divides by sine A minus 1. fraction, whole number, take LCM to simplify it. LCM is sin A. You get 1 plus sin A. LCM of denominator, again sin A. You get 1 minus sin A. Denominator is sin A, you can cancel directly or you can reciprocate it. So I am reciprocating it. 1 plus sin A divides by sin A into sin A divides by 1 minus sin A. Sin A cancels, which is equal to 1 plus sin A divides by 1 minus sin A. Left hand side is equal to right hand side 2. Similar sum you have, you can try question, and it is like this. Sec you have to prove 1 plus cos divides by 1 minus cos. Question number 12, part 2. I'll do similar sum, and you can try question number 12 too from the exercise. It is cos squared theta divides by cosec theta minus 1 whole squared equal to 1 plus sin theta 1 minus sin theta. Look at this question now. This is whole squared, so you don't have any identity. Change this. Take left hand side. Change cot squared using identity. And cot squared can be written as cosec squared theta minus 1. You have whole squared, so write it twice. Cosec theta minus 1. Cosec theta minus 1. Like a squared you have, so write a into a. It is whole square, so I am writing 2 times. At numerator, use algebraic formula, expansion, a squared minus b squared, which can be written as cosec theta plus 1, cosec theta minus 1, cosec theta minus 1, cosec theta minus 1. Like terms you cancel. You are left with cosec theta plus 1, cosec theta minus 1. On the right hand side you have to get sign now. So change cosec into sin. 1 divides by sin theta plus 1. 1 divides by sin theta minus 1. Take LCM of numerator, sin theta, 1 plus sin theta, LCM of denominator, sin theta, you get 1 minus sin theta. You can cancel directly if you have equal denominators. So at numerator you are left with 1 plus sin theta, 1 minus sin theta. Left hand side is equal to right hand side, proved. Bit confusing, but if you follow the steps, it becomes easier. Application of formulae and simple steps involved. Identity, simple expansion, cancellation, again identity formula, reciprocal relation, LCM, and then cancel it. Try question number 12 part 2 yourself, and please do memorize the formulae. Thank you very much. Stay safe.